what's up guys? So I promised you guys I'm going to draw videos on partial fractions. Okay, I'm still my humble self, I like to talk. So don't forget to turn on the notification button. Okay, so you can move with me whenever I upload on this platform. Alright. So good, today we are going to be discussing partial fraction. So what is partial fraction? Definition 1.1.0. We said that partial fraction is the method of combining two or more simple algebraic fractions to obtain a single algebraic fractions. You understand? There are some fractions you'll be given that you'll be asked to solve, and if you tend to use the normal way to solve it, it will be difficult for you to simplify. You understand? In that aspect, we introduce what we call partial fraction. Okay, so that's it. So these are the form of which we call partial fractions. Anyway, so definition 1.1.1. So this under the definition 1.1.1. So the next thing we are defining is whenever you see definition 1. Whatever or definition of a figure, so we are talking about definition of terms. Okay, so this is definition of terms. So now resolution into partial fractions. So is the process of transforming a compound algebraic fractions into a sum of partial fractions. So all these definitions are not really necessary, and at the same time it is necessary. So please just take your time to study these definitions, and that's it. So types of partial fraction, we just have 4 types of partial fractions as you can see above. So partial fraction with non-repeated linear factors at the denominator, and secondly we have the partial fraction with non-linear factors that are not repeated. Then thirdly we have partial fractions with repeated factors, linear or non-linear, and lastly we have the improper fractions. That's it. So we are going to be touching all these 4, but most especially you can be given some questions, then I'll be teaching you shortcuts to solving questions of partial fraction, and that shortcut is what we call the cover-up method. Alright, so we move. I'm going to clean this now. So I'm going to solve the first question. I just want you to get along with me. Alright, so we have the first question here. Worked example 1.0. Resolve. So x plus 3 over x plus 1, x plus 4 into partial fraction. So how do we resolve this? It's very simple, very simple. So solution. So you're having what? You're having 2x plus 3 over what? X plus 1, x plus, I'm going to be using 2 methods. I'm going to use the partial fraction with non-repeated linear factor, the method. So then I'll use this simple method you can use to save time. That's the cover-up method. So whenever you have a question like this, you can see, look at this, a non-repeated linear factor. So there's no repeated linear factor here at the denominator. So look at the denominator. So this is a factor. This is what we call a factor. We're having 2 factors here. Okay. So among these 2 factors, these 2 factors are linear. When you call what they call linear, when something is carrying the power of 1. So they are both linear factor. Okay. And among these 2 linear factors, none of the factors are repeated. But this, if I'm having something like x squared plus 1, that become a quadratic factor. So which you can also call your non-linear factor, because it's carrying power that is more than 1. Do you understand? So it's shown by having an expression carrying a power of 1. So it is called, you can call it a linear factor, linear expression, a linear factor. So these are the 2 linear factors, and they are not repeated. So now when you have this, what you do when you have a non-linear factor at the denominator, just equate it. Think of a constant or just alphabet. I'll think of a over what's the first linear factor we have here? X plus 1. Then plus it. So whatever, whether you have a minus or plus here, it will still be plus. So So that is the rule. So in case you have questions related you want to ask on that. So this next one is what x plus 4, but you think of another alphabet, b over the second linear factor. If you like, you can use p and q. It doesn't really matter. That doesn't really count. You can decide to use p over x plus 1 plus q over x plus 4. Or if you like, you can use I and j. I over x plus 1 plus j over x plus 4. So now at this junction, you write this, then 2x plus 3, x plus 1, x plus 4. So at this is the right hand side, okay? So at this region of right hand side, you take your LCM. So what is the LCM? The multiplication of this and this. So x plus 1, x plus 4. Then this denominator, this LCM divided by this. When this one divides this, let's say x plus 1, x plus 4 divided by this, x plus 1. This cancel this, you are left with this. So this one that you had as when you multiply by a, then you have a into x plus what? X plus 4. Alright. So the same thing, this one divided by this, it remains x plus 1. Hence also have times this. So b into x plus 1. That's it. So now you have to take it away from fraction. How do you do that? You're having common denominator here. You are having common LCM here. So what you do is you multiply through by x plus 1, x plus 4. You multiply through by the LCM. So by the time you multiply through, you're having x plus 1, x plus 4, all multiplied by 2x plus 3 over x plus 1, x plus 4 is equals to x plus 1, x plus 4 multiplied by a into x plus 1 plus b into x plus 1. X plus 4 here, sorry. Having x plus 4 here, so over x plus 1, x plus 4. Then this one cancel this, and this cancel this. Then we're having 2x plus 3 is equals to a into x plus 1 plus b into x plus 1. Alright, so now at this junction, we can, if you want to, we want to find, there's a mistake. This one is x plus 4, okay? A into x plus 4 plus b into x plus 1. So let's suppose that we want to find a first. So if you are finding a first, so you equate this factor here equals to 0. So let x plus 1 equals to 0, which implies that x is equals to what? Equals to minus 1. Understand? We are finding a. So since we are finding a, we can make this factor attached with b equals to 0. So you make s of your formula from that. So anywhere you see x here, you input minus 1. So you're having what? That's 2 into minus 1 plus 3 equals to a into minus 1 plus 1 plus b into minus 1 minus 1 plus 4. X is minus 1 plus 4 plus into minus 1 plus 1. Alright, this one we are having what? Minus 2 plus what? Plus 3 equals to a into minus 1 plus 1 is what? 3. Then this one is b into minus 1 plus 1 is 0. So now this one minus 2 plus 3 is what? 1 equals to 3a plus what? 0 times b is 0. So having 3a is equals to 1, which implies that a is equals to 1 over 3. We divide both sides by 3. So that's how we came about that. So no stress. So now we have already gotten our a. So to get our b now, we make the factor of this a side to be equal to 0. So let what? X plus 4 equals to 0 to obtain what? To obtain b, which implies that x equals to what? Minus 4. So anywhere you see this this equation star. Anywhere you see x here, you do the same thing, you repeat the same process. Anywhere you see x here, you put minus 4. That is 2x plus 3 equals to a into x plus 4 plus b into x plus 1 equation star, right? When x equals to minus 4, and between 2 minus 4 plus 3 equals to a into minus 4 plus 4 plus b into minus 4 plus 1. So this one is gone. So we are having minus 8 plus 3 is equals to what? Is equals to minus 4 plus this is minus 3 and b. This one minus 4 plus 4 is 0. So that's why I cancelled it out. So you're having what? Minus 8 plus 3 is that is minus 5 is equals to minus 3b. Then this one cancel this. It implies that b is equals to 3 over 5. You can see that way, it's very easy. So we've been able to show that a is equals to 1/3 and this one is 3/5. So now we now come back here, hence, or you can say therefore, okay, let me just put hence. So a over x plus 1 plus b over x plus 4 is equals to, what do you get for your a? We get 1 over 3. That's 1 over 3 into x plus 1 plus what that will be 3 over 5. That's 3 over 5 into x plus 4. So this is our final answer. So it is plus that is here. So you will see very well that at the end of the day, you expand this. If you solve this one normally, like solve it, expand it, you will get the same answer as this. Try it. By the time you try it, you will get the same thing as this. It means your answer is correct. But if at the end of the day you expand this one, you are not getting the same value as this, then something is wrong somewhere. So you need to figure it out and make sure that you do things rightly. So now I'm going to be using the cover-up method to solve it. In case you feel that okay, this method is too long, I'm going to use the cover-up method so you can get it right. So no stress about that. Alright, so I'll be cleaning this now. Should I use the same question or change the question? Let me find another question. Let me use this question. Should I use it? If I'm using this question, we should okay. Alright, so I feel that I should use another question before, but let me just use the other method. So now, quick one, the shortcut method, using what? The cover up method. Now using the cover up method here. So what you do is that, assume, just close your eyes like you don't see what you have there. Then what you have left, you're having 2x plus 3 over x plus 4. You understand? So, and you see clearly that this one that we close eyes for was what was under this one. Since we close eyes for this one, it will not be here anymore. So you will be having left your a, because you are closing eyes as if you don't have anything that has to do with this first one. Obviously this one is gone, n plus. So this one that we close eyes for, that we as if we don't have. So it's going to be multiplied by b here. Are you with me? But this one still remains in its position, nothing is taking its place. Alright, so at this junction, let the factor on this b, because this one is not having a factor, x equals to minus 1. Let x plus 1 is equals to 0, which implies that x equals to minus 1. So we can make this one equation star 1. Right, so substitute So doing that, at the end of the day, we'll be having what? We'll be having 2 into minus 1 plus 3 over minus 1 plus 4 equals to a plus b into minus 1 plus 1 over minus 1 plus 4. Okay, so at the end of the day, you have minus 2 plus 3 minus 2 plus 3 over minus 1 plus 4 equals to a plus minus 1 plus 1 is 0. At the end of the day, 0 times b is 0. 0 by any number is 0. So this is 0. This one is what? 1 over what? Minus 1 plus 4. You are having what? 3 equals to a, which implies that a is equals to 1 over 3. You can see this one is so short. So to solve for b, now we are taking care of a now. So you know that this other factor is for b. Okay, so we will assume that we did not see this one. Like we close eyes for this one the way we did initially. So when we close eyes for this one, it will be left with this. So that will be 2x plus 3 over x plus 1, right? Equals to, which one did we close eyes for? We closed eyes for this one. So since we are closing eyes for this one is automatically gone here. We will write the remaining thing that we have left. A over what? A over x plus 1. This a, the one that we close eyes for, will be attached to this a. Are you understanding me? Are you getting me now? Because we are looking for b. So plus what? B. You can see what's going on there. So now at this junction, which one are you close eyes for? This x plus 4. So let what? X plus 4 equals to 0. So this one is our equation, start 2. So which implies that x equals to minus 4, right? So you are going to substitute for x into equation start 2. So doing that, we are having what? 2 into what? Minus 4 plus 3 over minus 4 plus 1 is equals to a into minus 4 plus 4 over minus 4 plus 1 plus what? Plus b. And this one is gone, is 0 automatically. So we are having b is equals to what? Minus 8 plus 3 over minus 4 plus 1. Okay, so which is minus 5 divided by what? Minus 3. This one, okay, my goodness. Hope I've not made any mistake. There's an error here. 8 plus 3 minus 8 plus 3. Okay. A is equals to okay. Alright. So this one take care of this one. So we are left with b equals to 5 over 3. And so we have our a and we have our b. Alright. So at the end of the day, we arrive at same answer. Is that clear? We arrive at same answer. So it's still the same thing anyway. So you can just put it. So you can put it like this, like 1 over, if you substitute this one here, 1 over x plus 1 plus 5 over 3 into x plus 4. Right? What is common? 1 over 3 is common here. You can bring it out. In case if it's an OBJ question, 1 over 3 is common here, you know. So you won't be like, how manage x plus 1 plus 5 over x plus 1. So either of the two methods is perfectly okay. So this is what you call the cover-up method. So we are going to be moving on to okay, I'm going to be moving on to another example. We have enough example here, so I'm going to move on to another example. So we move. So